Assalamualaikum and hi. We are from BMID Section 1/1. Want to present our project about traditional lighter in course Technology CNC. The code is BMID 3523. The lecture coordination was TS Dr. Syahrul bin Sundi. For the group member, my name is Muhammad Zakwan bin Zakaria. Number metric B0922100063. Second, Muhammad Firdaus bin Abdul Razak. Number metric B09221058. Third, Nurin Nadiah Binti Azmi. B0922100134. And last, Thuraya Balqis Binti Azlan. Metric number B0922100417. Okay, for introduction, the traditional lighter, or we call a fire piston, also known as a fire syringe, is a primitive fire starting device that utilize rapid compression to ignite a small piece of tinder. For the origin and history, the fire piston has been used for centuries, primarily in South Asia and Pacific Island. It predates the invention of match and lighter. Okay, for the fire piston, they have three components used. The first is cylinder, the second is piston, and third is tinder. For the cylinder, a hollow tube, typically made of wood, bamboo or metal. For the piston, a rod that fit snugly into the cylinder, offer with a small chamber at the end of whole tinder. Okay, for the tinder, flammable material like chalk, coke, dry grass or cotton. For you choose fire piston, first insert tinder into the end of the piston. Second, push the piston swiftly and forcefully into the cylinder. Third, withdraw the piston to reveal the ignited tinder. And lastly, transfer the ember to a largest tinder boundary and blow gently to start a fire. For advantage, simply durability and reliability in various weather conditions. Do not rely on chemical or modern material. And for the consideration, request practice to master the technique. And lastly, quality of tinder is curious for successfully ignition. In addition, drawing for turning part, we using SolidWorks for making our drawing. The length was 130mm and the diameter was 79mm.
Today I will explain you guys about the coding. And first, of course, we use the same header, which is G19, G95, G71, G18 and G54. And for the workpiece, we use the length 160mm and the diameter is 50.8mm. And for the counter turning, we use the first tool we use is plunger cutter, and the second one we use a finishing tool. And of course, for the finishing, we also use the plunger cutter, and then the next one is finishing tool. The last one we use the same plunger cutter also. And of course, for the last of the coding, we use the till, which is M05, M03, and M30. So that's all from me.
Furthermore, for transfer our coding, we using Sinotrain for transfer our coding and making simulation.
Discussion. In this project, we explore the application of CNC turning technology to fabricate a fire piston or lighter, traditional lighter. Design and engineering consideration, tolerance and fit. Achieving a precise fit between the piston and cylinder was critical. Tight tolerance were maintained to ensure the necessary proportion, highlighting the importance of CNC turning in achieving such precision. Material selection. Choosing the right material was vital. Metals like aluminium and brass were selected for their durability and thermal properties. The material choice impact the machining process and the final performance of the fire piston. CNC turning process. Tool selection. Various tools were used to achieve the desired features, including boring tools for the cylinder and forming tools for the piston. The selection of tools influenced the surface finish and dimensional accuracy. Program and setup. The CNC machine was programmed to execute the turning operation with high precision. Proper setup and calibration were essential to ensure consistency across multiple parts. Machining parameters, cutting speed, feed rate, and depth of cut were optimized to balance machining time, and surface quality. These parameters were critical in achieving the desired surface finish and dimensional accuracy. Quality control and testing. Dimensional inspection. Components were inspected with micrometers and calibers to ensure that they meet the specific tolerance. This step was crucial to verify the fit and functionality of the fire piston. Functional testing. The assembled fire piston was tested for its ability to generate an ember. This involved multiple trials to ensure reliability and consistency in performance.
My name is Firdaus. Today I would like to present about inspection of CNC lathe. Okay, our part name is fire piston. We using CNC lathe machine. Quantity product using one workpiece. Using material from aluminium. For the left side of the inspection, they show the number, dimension, tolerance, range, and method. We have 7-step dimension using CNC. Using caliper to measure the workpiece, and our tolerance between 0.1 and negative 0.1. Okay, last but not least is conclusion. In conclusion, the CNC turning process provide to be an effective and precise method for manufacturing the component on a fire piston. Here are the key points from the project. Okay, the first one is precision and accuracy. CNC turning allow to produce highly accurate and uniform parts, ensuring a snug fit between the piston and cylinder. Okay, next, material selection. Okay, the choice of materials such as aluminium or brass for the cylinder and piston provide the durability and heat resistance required for repeat use of the fire piston. Okay, and then number 3 is design optimization. Okay, CNC technology facility easy modified and and fine-tuning of the design, optimizing the dimension and ensuring the efficiency of the compression process. And then quality control. The CNC turning process include rigorous quality control measure, ensuring each component met the requirement specification and function properly. Okay, then efficiency. Okay, automation and precision of CNC turning slightly reduce manufacturing time and minimize material waste. Then challenge and solution. Challenge such as achieving the perfect seal and maintaining considered compression were addressed through iterative design adjustment and precise machining. Last but not least is practical application. The final product demonstrate reliable perform in the active tender, validating the efficiency of the using CNC turning of manufacturing fire piston. Overall, the CNC turning project successfully delivered a highly quality fire piston that meet functionally requirement and stand up to a practical use, showcasing the advantage of the modern manufacturing technique in produce traditional book. Okay, thank you.